All right, so we have graphed linear functions, and in the last lesson learned that the points that lie on a graph are simply the xy pairs that make the equation true. So graphing an inequality in the xy plane is exactly the same. So when you're graphing inequalities, what you are essentially doing is you're plotting or shading all xy pairs that make the inequality true. So let's look at the inequality y is more than x plus 3. So we need to determine if any of these are in the solution set. So is 7 more than 2 plus 3? Is 7 more than 5? Yes. So this one would be in the solution set. Is 1 more than 0 plus 3? Is 1 more than 3? No. This would not be in the solution set. And finally, is 4 more than 1 plus 3? Is 4 more than 4? No, this would not be in the solution set either. So let's graph this line, y equals x plus 3, but it says to put it in a dashed form. So our y-intercept is 3, so that's where we start on the y-axis. And remember, when you don't have a number in front of an x, it's an understood 1. So from our starting point of 3, we go up 1 over 1. And we're going to do it across the entire coordinate grid. So why are points that lie on this line not part of the solution set of the inequality? Remember, the inequality is y is more than x plus 3. Well, the reason why they're not part of it is because there isn't the or equal to. So this means that this line is a dotted line, so anything that comes up on that line itself will not be true. So plot 3 points from part A and use them to help you shade the proper region of the plane. So our first point is 2, 7. So 2, 1, 2, 3, 4, 5, 6, 7. And that one was true. Our next one is 0, 1. So 0, 1. And our last one is 1, 4. So we remember that this point up here was true. So that means that we are going to shade everything on that side of the graph. The reason why you don't use the point that landed on it is because there's not an or equal to in the equation. And we already knew that this point down here was not true because it didn't come true in the when we put it into the equation. So that one is not true. Choose a fourth point that lies in the region you shaded and show that it is in the solution set. So you can pick any point. I'm going to pick this one right here. So that point is 0, 1, 2, 3, 4, 5. So I want to prove that 5 is more than 0 plus 3. 5 is more than 3, so it's true. The point 10, 12 cannot be drawn on the graph grid above, so it is difficult to tell if it falls in the shaded region. Is 10, 12 part of the solution set? Well, all we have to do is plug it in to the original equation. Is 12 more than 10 plus 3? Is 12 more than 13? So no, it is not a part of the solution set. Here are some challenges to graphing linear inequalities, especially if the output y has not been solved for. Let's look at the worst case scenario. So we need to first rearrange the left-hand side of this inequality using the commutative property of addition. So we're going to take 3x minus 2y is more than or equal to 2, and we need to move the x to the other side. So subtract 3x from each side. So negative 2y is more than or equal to negative 3x plus 2. Divide by negative 2. But what we learned about inequalities before is when you divide or multiply by a negative number, you're going to switch the inequality. So now y is less than or equal to 3 halves x minus 1. So that is all of A and B. C says to shade the solution set of the inequality on the graph paper below. So we need to first graph it. So our y-intercept is -1. Our slope is up 3 over 2. So up 3 over 2, and we do as many that we can fit on the graph. Because it's or equal to, this is going to become a solid line. So what that means is, if you find a point that lands on the graph, what's up? If you find a graph that, or a point that lands on that graph, then it will also be true. So we need to shade this. There are two ways to do it. You can pick a point and see if it's true, or we can simply look at our inequality. So if you want to pick a point, if I pick point 0, 0, and plug it in, is 0 less than or equal to 3 halves times 0 minus 1? Is 0 less than or equal to -1? No, it's not true. So since that one's not true, then we have to shade the opposite side. So this side gets shaded. But the other thing we can look at is y is less than or equal to. So we look at what point of the, if we are looking at the y-axis as itself, so just the y-axis, at what point from our original graph is y less than? Well, less than it would be underneath it. Those numbers that are below our starting point are less than. So you could look at just the inequality, or you can plug a point in to decide which side to shade. All right, letter D says pick a point in the shaded region and show that it is a solution. So let's pick a random point. Let's say that we pick the point 2, 0. So is 0, oh wait, original inequality, sorry. So original inequality means you're going to use the original thing you're given up here. So 3 times 2 minus 2 times 0, is that more than or equal to 2? So we plug the 2 in for x and the 0 in for y. 3 times 2 is 6. 2 times 0 is 0. So 6 is more than or equal to 2. The final type of inequality that we should be able to graph quickly and effectively is one that involves either a horizontal line or a vertical line. So let's shade the solution set for each of the following inequalities in the xy planes provided. But first, state in your own words the xy pairs that the inequality is describing. So in your own words, the first one, x is less than 4. So we're going to find 4 on the x-axis. This one will be a dotted line or a dashed line because it does not have the or equal to. And now we need to shade everything where x is less than 4. Well, everything that x is less than 4 is over here. Because you think about the points, if you were to look at this point, 3 is less than 4, 0 is less than 4, negative numbers are less than 4, so everything shaded to the left of that line. Next one, y is more than or equal to -2. So we go to -2 on the y-axis. Because it's or equal to, it's going to be a solid line. And now we need to think everything that's more than -2. Well, everything that's more than -2 is everything up here. If you were to pick any point, like 0 is more than -2, 4 is more than -2. So those are all true.